Hi, Bobcats. In this video, we're going to look at binary ionic nomenclature again. This time, we're going to look at the procedure for writing names and formulas. Remember that ionic compounds are composed of a metal and a nonmetal. At a later date, we'll incorporate polyatomic ions as well. So this table shows you some covalent compounds as well as some ionic compounds. I want you to pause the video, look at this for a moment, and see what's the same, what's different, because we've already covered the covalent nomenclature, so what's different here with the ionic nomenclature? Pause the video. Great, now that you had a moment to look at that, I want to point out a couple of things. Whether it's ionic or covalent, the ending of the second element is changed to IDE. The name of the first element is left alone. We don't change carbon to carbide in the first example. We don't change lead to leadide or something like that in the first example of the second column. We just call it lead, we just call it carbon. But something that's different between covalent and ionic nomenclature is prefixes, right? The prefixes disappeared for ionic nomenclature, and also in ionic nomenclature, lead had this Roman numeral appear. Okay, so those are some differences. So you might be thinking, well, if we don't have the prefixes, how do we know what subscripts to write? Well, that's what we're going to tackle on the next slide. So, how do we know the subscripts to write if we're not given the prefixes? Our big idea is that the total charge has to cancel out or add up to be 0 to make a neutral compound. So in something like sodium chloride, sodium's got 1 positive, chloride's got 1 negative, plus 1 minus 1, that adds up to 0. Magnesium oxide, similar process. Magnesium's got 2 positives, oxygen's got 2 negatives, plus 2 minus 2, that adds up to 0. Let's look at that big idea in a little more detail. Your cation, that's your metal ion. It's got a positive charge. Your anion, the nonmetal, has a negative charge. We need to bring enough of each cation and each anion that we end up overall with a 0 charge. So if we're going to make a compound between iron 3 ions and oxide ions, if we take one of each, we've got too much positive charge because we've got 3 positives and 2 negatives. All right, well, let's get some more negative charge. Well, the problem is we can't get just 1 negative because oxide brings 2 negatives. So now we've got too much negative charge. We have 4 negatives and only 3 positives. So let's get some more positives. Well, if we take another iron 3 ion, now we have 6 positives, but only 4 negatives. So let's get another oxygen. Finally, now we have 6 positives and 6 negatives. This would be a neutral compound. So if we're going to make a neutral compound between the iron 3 ion and the oxide ion, we need 2 irons and we need 3 oxygens. Now, if I had to go through that process every time I wrote the formula for an ionic compound, I probably would not be a chemist. There's an easier way. We're going to do something called crisscross. The details are spelled out here. I want to just jump into working some examples because I think all of those words make it look much harder than it actually is. So let's read the formulas for these compounds. The first one, sodium chloride. We already know that should be NaCl, but let's go through and look at the process. In order to do this, you are also going to need your periodic table, so pause and get your periodic table if you don't have that handy. Okay, sodium chloride. Sodium is in group 1. And so we know all of those alkali metals have a 1 plus charge. Chloride's a halogen. All of the halogens have a 1 minus charge. So after we write the symbol for the ion and its charge, ask yourself, does the charge cancel out? In this case, yes, it does. If the charge cancels out, we just need one of each. So we don't need any other subscripts. We just write Na Cl. Your final answer for the formula should not show any charges. It can have subscripts, but it can't have any charges. Barium bromide. Barium is in group 2, an alkaline earth, and so barium has a charge of 2+. Bromide comes from bromine, which is also a halogen like chlorine in the previous example, so it's 1-. The 2 positives and the 1 negative don't cancel out, so this is where we're going to crisscross. We are going to take just the number, not the sign, just the number, and cross it down as the subscript on the other ion. We'll bring this 1 down on barium. When we clean this up to write our final answer, we don't write a subscript of 1, and we don't write any charges. So what we write is Ba Br2. We do have to write that 2 subscript, but a 1 subscript we don't write. Now the reason this works is that if we're going to add up the total positive and the total negative charge, the quickest way to do that is to take the subscript on each ion and multiply it by the charge. So barium has an understood subscript of 1 with a charge of 2+, so 1 times 2+ gives us 2+. Bromine has a subscript of 2, but each one of those has a 1- charge, so 2 times 1- gives us 2-. So we end up with 2+ and 2- because we're basically multiplying the same numbers together, just with opposite signs. So this crisscross process makes the charges add up to 0. On the next one, we've got copper 2 chloride. Now, don't go to the periodic table to find copper's charge because it's not a fixed charge ion. That Roman numeral 2 is telling us that in this case, copper has 2 positive charges. Copper also is commonly 1 positive, but in this case, it's the 2 positives. So we have Cu2+. Chloride, being a halogen, is still 1-. 2 positives and 1 negative don't cancel out, so we're going to crisscross. I'll bring that 1 down on copper as well. When we write our final answer, we don't write any of the charges that we've written up top. We don't write any subscripts of 1. So our final answer is CuCl2. Last but not least, aluminum oxide. Since there is no Roman numeral on aluminum, it must be a fixed charge one. We go to the periodic table. We find that aluminum is in group number 13, so its charge will be 3+. Oxygen is in the chalcogens. That whole family goes 2-. So when we go to write this, we've got Al with a 3+, we've got oxide with a 2-. The +2 or +3 and -2 don't cancel, so we are going to bring the number from the charges down as the subscript on the other guy. That means crisscross, or that's what's meant by crisscross. Cleaning that up in the end, we have Al2O3. We write subscripts but not charges. All right, here's another one where you have the opportunity to practice. I would like for you to pause the video and write the formulas for these. So go ahead and pause it now. Great, I'm going to assume you've paused it. That Roman numeral 3 on indium tells us that it's a 3+. Bromide's a halogen, so it's going to be a 1-. So we have ion 3+. Br 1-. Those don't cancel out. So when we crisscross, we end up with 1 indium and 3 bromides. So that's going to be InBr3. On the next one, the Roman numeral 6 tells us chromium is 6+. Sulfur is in the chalcogens, so the sulfide ion has a 2- charge, just like oxygen and everybody else in that group. So when we go to write the formula, chromium is 6+, sulfide is 2-. When we crisscross, we bring the 6 down on the sulfur and the 2 down on the chromium, and that's going to give us Cr2S6. But don't stop here. Remember that all ionic compounds should use empirical formulas, or the smallest whole number ratios. 2 and 6 can both be divided through by 2, so this should be written as CrS3. We want to go ahead and do that reduction to the empirical formula. The next one, lead 4 oxide, that Roman numeral 4 tells us that lead is 4+. Oxide, being a chalcogen, is 2-. So this is going to be Pb4+, O2 minus. The 4 and the 2 don't cancel out, so we're going to have to crisscross. And that gives us a formula of Pb2O4. But once again, those can be reduced. So we want to take that all the way down to PbO2. And last but not least, we have barium selenide. Selenium's in the same family as sulfur and oxygen, so it's going to have a 2 minus. Barium is an alkaline earth. It's going to be 2 plus. So when we go to write the formula, we've got Ba2 plus, Se 2 minus. The positives and the negatives cancel out, so we don't need any subscripts. We just need one of each. Whoops. And that's going to be BeSe. I'm sorry, BaSe. If you forgot and you crisscrossed, you would end up with Ba2Se2, and hopefully you recognized that you needed to reduce that to BaSe.